Good morning, afternoon, or evening, cats and dogs. This video is going to focus on the lesson 7.5 guided notes on factoring linear expressions. This is a really important concept because in algebra, which you'll take next year, factoring essentially is an entire unit. So you'll spend a lot of time working with factoring expressions, and we're going to be working first with factoring linear expressions using the greatest common factor. So let's begin by talking about what the greatest common factor is. The greatest common factor is the GCF, and this is already on your paper, so you don't have to copy it down. But the GCF is the largest number that is a factor of two or more numbers or monomials. Now that word monomials sounds a little scary. Don't worry, we'll talk about what they are. It's nothing extremely complicated. So when I'm trying to identify the GCF of a pair of numbers or three numbers or more, I try to look to see if the smaller number goes evenly into the larger number. If so, then the smaller number is the GCF. A good example of this would be example 2 down here. So we've got finding the GCF of 4 and 8. Since 4 goes into 8 evenly, that means 4 is the greatest common factor, which means that 4 is the largest number that both 4 and 8 divide by. If not, find factors of the smaller number just because they're usually a little bit easier to find, and determine if they are also factors of the larger number. So a good example of this would be example 1, finding the GCF of 24 and 60. So since 24 does not evenly go into 60, 24 is not the greatest common factor. So other factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Those are the numbers that 24 divides by. Back in elementary school, you might have done like little rainbows over these, like 1 and 24 gets you 24, 2 and 12 gets you 24, 3 and 8, 4 and 6. So you would make a rainbow out of this. If that's the easiest way to list them, that's fine. I would expect that for the problems we're going to see, you're probably not going to have to probably not going to have to list them all out in any case. It'll be easy enough to find them without listing out all of the factors. I want you to keep in mind we've already talked about least common denominator, which was the least common multiple of two numbers. This is greatest common factor. This is different. So factors are smaller than the numbers. The multiples are the ones that are bigger than the numbers. So just keep in mind the differences between those. So anyway, factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Well, 24 doesn't go into 60 evenly, 12 does, and I go from highest to lowest because I want the greatest common factor. So that means 12 is the GCF. One thing that I do is I will take each number and divide it by what I think the GCF is. Like I'll take 24 divided by 12, it gets me 2. 60 divided by 12 gets me 5. And I check to see if those quotients are divisible by anything besides 1. 2 and 5 do not divide by anything besides 1. So that tells me that 12 was my greatest common factor. All right, so in the case of two monomials, you might be thinking, what in the world are monomials? These are expressions that contain variables. That's all they are in this case. When you go into algebra, you'll talk about binomials and trinomials, so you'll go beyond monomials. The GCF will include any variable or variables that the two monomials have in common. So let's look at some examples. So examples 3 and 4. Example 3 asks us to find the GCF of 8x and 12x to the second power. So first thing I would do is find the GCF of 8 and 12, the largest number they both divide by. Well, that's 4. Okay, so you can see that right here. Now let's look at what variables they have in common. 8x has 1x attached, and 12x to the second power has 2x's, right? X times x. So what do they have in common? They have 1x in common, 1x that I could take from each of these. So what does that make my GCF? 4x. Let's look at example 4. We've got 30xyz and 45xz. So find the greatest common factor of 30 and 45. That is 15. And I'm not going to read through all of this. You can look over that if need be. But that's the largest number they both divide by, 15. Now, what variables do they have in common? Looks like we've got xyz and xz. So they both have an x and a z in common. So my GCF is 15xz. All right, so let's start off with some examples of identifying the greatest common factor of two numbers or two monomials, or in the case of one of the examples, three numbers. So what about the GCF of 21 and 27? Think through these as we're working through. Pause the video if you need to, and we'll take a look at each. All right, the largest number that 21 and 27 are both divisible by is 3. Again, a good way to check this is take 21 divided by 3 is 7, 27 divided by 3 is 9, and there's nothing that both 7 and 9 divide by besides 1. What about 12 and 48? Well, 12 goes into 48 evenly, exactly 4 times. So I know that 12 is going to be my greatest common factor. Ooh, I don't know what's going on. My computer's going wackadoodle right now, so hopefully it's still working all right. So 12 is going to be my greatest common factor. It's the largest number that both 12 and 48 are divisible by. Number 3, what about 18 and 24? 18 and 24 are both divided by 6. It's our greatest common factor. It's the largest number they both divide by. What about 6, 12, and 15? I need all three numbers to divide by this number. It is indeed 3. 6 divides by 3, 12 divides by 3, and 15 divides by 3. What about 25 and 100? 25 goes evenly into 100, therefore 25 is my greatest common factor. What about 20 and 25? 20 and 25 both divide by 5. That is my greatest common factor. Next one, 49 and 56. Both divide by 7, so 7 is going to be my greatest common factor. Number 8, we have 45 and 54. What do they both divide by? Well, they both divide by 9. All right, let's take a look at our monomials. 15x to the third power and 18x. 15 and 18 both divide by 3. And then x to the third power has 3 x's attached. X just has 1 x attached, so what can I pull from both of them? A single x. Number 10, 12ab and 36a. The largest number that both 12 and 36 divide by is 12, since 12 goes into 36 evenly. We've got a, b, and a. What do they have in common? An a. Number 11, 18x to the fourth power and 27x to the second power. 18 and 27 both divide by 9. There's 4 x's attached here, 2 attached here, so the most I can take from them is 2 x's to get x to the second power. Number 12, 3x squared y, 9xy squared. Both 3 and 9 divide by 3. I can take an x and a y from each of these. Keep in mind that the 3x squared y is an x multiplied by an x multiplied by a y, whereas the 9xy squared is an x multiplied by a y multiplied by a y. It's not xy, xy. So xy squared means the y is squared, not the x. So I've got an x in common for each of those, and I have a y in common. So I can take an x and a y from each of these. Take an x, take a y. So 3xy is my GCF. I don't want you to panic too much about the monomials. It's something that we'll see a little bit of here, but it's not the most important or the biggest part of this lesson. The biggest part is going to be factoring using the greatest common factor. So there's 3 steps. The first thing is to find, and again, these blanks are already filled in for you, find the greatest common factor of the 2 terms. That's why we just talked about it. Rewrite each term as the product of the GCF and its remaining factors, which we'll show you how to do. Finally, write the GCF outside the parentheses. The remaining factors in operation will be left inside the parentheses. Basically, we're undoing the distributive property. So if you want to check to see if your answer is correct, you can use the distributive property to multiply it out and see if it's equivalent to what you started with. So for example, just move that down a little bit. In example 4, which I'm not going to go through all of these examples, 2x plus 6 factors into 2 and then in parentheses x plus 3. If I use the distributive property, 2 times x gets me 2x, which is what I started with. 2 times 3 gets me 6, which is what I started with. So it's one way to check to see, is my solution correct? So let's get right into some examples. I also have an extra practice sheet for this lesson, so you'll get a chance to practice this both in class and on your own if need be. So number 13, we have 3n plus 12. My greatest common factor is 3. So I rewrite this as 3 times n plus 3 times 4. Notice how it's a product of my GCF 3 and what's left behind. 3 times n gets me 3n, 3 times 4 gets me 12. So the 3 is going to go outside the parentheses, as you can see, and then inside the parentheses will be what's left. So the green highlighted things. When I take the 3 out, I'm left with an n, and I'm left with a 4, and of course my operation of addition. So 3 and then in parentheses n plus 4. That's factoring the expression. The one thing students get confused about is they think if it says factor each expression, it just means to find the greatest common factor. It doesn't mean just find the greatest common factor. If I wanted you to find the greatest common factor, it would say that. Factoring it means to basically, factoring the expression in this case basically means to undo the distributive property. All right, number 14. Let me just circle my final answer here so you know this guy right here is my final solution. Number 14, 5x plus 10. My GCF is 5, so we'll rewrite this as 5 times x plus 5 times 2. Again, my GCF shows up in both of these. 5 times x gets us 5x, 5 times 2 gets us 10. So my final solution will be 5 and then in parentheses, x plus 2. Number 15, 9m plus 12. The GCF of 9m and 12 is 3. So we'll rewrite this as 3 times 3m. That's where this one gets a little bit more challenging. 3 times 3m gets us 9m, and then 3 times 4 gets us 12. So the 3 goes outside the parentheses. What's left is what I'm going to highlight in green here. Your 3m and your 4, those will go inside the parentheses. So final solution, 3, and then in parentheses, 3m plus 4. All right, moving right along. Number 16, 15 plus 25x. The difference here is that you have your constant first and then your term with variable second, but we treat it the same. GCF is 5. We'll rewrite this as 5 times 3 for 15 and 5 times 5x for 25x. 5 goes outside the parentheses. What's left is going to be your 3 plus 5x. Again, double check it. 5 times 3 is 15. 5 times 5x is 25x. Number 17, we have two monomials, a to the second power and 7a. They do have a common factor of a because I can take an a from each of those. So I'm going to rewrite this as a times a for a to the second power and a times 7 for 7a. So again, you're going to see that GCF showing up in each of these. So take the a, put it outside the parentheses. What's left is what I'm going to highlight in green here, the a and the 7, and the plus sign, of course. So your final solution is a, and then in parentheses, a plus 7. A times a is a squared. A times 7 is 7a. Number 18, we have 14b plus 28. GCF is not a, it is 14. Now it worries me that I don't have my right solution copied down. We'll see. GCF here is going to get us 14. I did copy the same thing twice. No big deal. We can type this in. So I'm going to take a 14 out of this. So I'm going to write 14 times b. I'm going to use parentheses to represent multiplication. It's easier to type in. Plus 14 times 2 for the 28. So the 14, our GCF is going to go outside the parentheses. B plus 2 is left inside the parentheses. So final solution, 14, then in parentheses, excuse me, in parentheses is B plus 2. All right, number 19. So we've got 8 plus 48r. The greatest common factor of 8 and 48 is going to be 8. 8 times 1 gets us 8. 8 times 6r gets us 48r. So the 8 goes outside the parentheses. 1 plus 6r is left inside the parentheses. Something to mention is that you probably will eventually get to the point where you can just go right to the final solution without having to write this work or this step. And that's great if you're already there. So feel free to give that a try by saying, okay, I know the GCF is 8. 8 times what gets me 8? That's 1. Plus 8 times what gets me 48r? Well, that's 6r. So you can factor this without having to show work if you feel comfortable. Number 20, 4n to the second power plus 16n. Our GCF is 4n. 4n times n gets us 4n to the second power. 4n times 4 gets us 16n. So the 4n is going to go outside the parentheses. N plus 4 is left inside the parentheses, for this being our final solution. Now in question number 21, we see our first question with subtraction. Guess what? You don't really treat this any differently. Find your GCF of 8 and 12, which is 4. We've got 4 times 2w for 8w, 4 times 3 for 12. And the 4 goes outside the parentheses. Inside the parentheses, though, you're going to have 2w minus 3 instead of 2w plus 3. I've had some students ask, can we add the opposite before factoring? Absolutely. You'll just have 2w plus negative 3 inside the parentheses. I don't suggest when you're factoring expressions to add the opposite since you're not moving things around, but you can do it. All right, last 3 of these before we do a few or a handful of word problems. Number 22, 12p minus 12. Our GCF is 12. So we rewrite 12p as 12 times p, and then 12 is 12 times 1. 12 goes outside the parentheses. You have p minus 1 inside the parentheses. The important thing here, by the way, is that you recognize 12 times 1 gets you 12. You do have to have this 1 inside of the parentheses. Number 23, 6g minus 39. Greatest common factor is 3. 6g becomes 3 times 2g. 39 becomes 3 times 13. 3 goes outside the parentheses. 2g minus 13 inside the parentheses. Finally, number 24, we have 3 terms, but we factor it just the same. 7x, 14y, and 28. The GCF is 7. So we write this as 7 times x plus 7 times 2y minus 7 times 4. 7 goes outside the parentheses. X plus 2y minus 4 is left inside the parentheses. All right, so I did put 5 independent practice problems here for you to try. Pause the video, give these 5 a try. All right, so hopefully you've worked through these 5. Let's take a look. The GCF of 8 and 16 is 8, so the 8 goes outside the parentheses. X plus 2 is inside the parentheses. Number 2, the GCF here is 3. 3 times 2y gets you 6y. 3 times 7 is 21. So it's 3 and then in parentheses 2y plus 7. Number 3, your GCF is 5. 5 goes outside the parentheses. 2z is inside the parentheses minus 5. 5 times 2z is 10z. 5 times 5 is 25. Number 4, GCF is 5. 5 goes outside the parentheses. X minus 4 inside the parentheses. Number 5, GCF is 9. 9 times 2x gets us 18x, and 9 times 5 gets us 45. So it's 9, and then in parentheses, 2x plus 5. All right, as promised, we have a few word problems. Let's take a look at these guys. So number 25 is already done for you. Feel free to read through it. We're going to start with number 26. The area of a rectangle is 5x plus 15 square feet. Factor 5x plus 15 to find possible dimensions of the rectangle. So the area of a rectangle is length times width. So let's factor 5x plus 15. The GCF is 5. So this breaks down into 5 and then in parentheses x plus 3. So if it's length by width or length times width, then my dimensions can be 5 feet and x plus 3 feet. Seems kind of weird to write it that way, but it is a way to look at some more challenging algebraic problems that also incorporate a little bit of geometry. All right, let's try another one of these. Number 27. The area of a rectangle is 12x plus 18 square meters. Factor 12x plus 18 to find possible dimensions of the rectangle. GCF is 6, so it factors into 6, and then in parentheses 2x plus 3. So my possible dimensions are 6 meters and 2x plus 3 meters. All right, last question. Number 28. 8 friends went to a soccer match. They paid for admission to the match and $24 for parking. The total cost of the visit can be represented by the expression 8x plus 24. What was the cost of the visit for one person? That should be a question mark. Let's factor 8x plus 24. Luckily, the GCF is 8 since 8 friends went to the soccer match. So I factor out an 8 and it becomes 8 and then in parentheses x plus 3. So a way to represent the cost of the visit for one person, since it's 8 for 8 people times the cost, basically tells us that x plus 3 is the cost per person. I don't believe you have any factoring questions like this, word problems, on your test, but it's still good to start taking a look at these for when you do see this again in your algebra class next year. All right, as I stated already, we are going to get some independent practice with this, both in class, outside of class. There's a practice quiz that goes along with this lesson as well, so that you get a chance to just kind of become more familiar with factoring expressions. Thanks for listening.